Hi everyone. A little while ago I did a video where I made a CNC lathe using the bits from my CNC 3018 milling machine, mainly just to see if you could just take control board and the stepper motors, rearrange them and use them as a different sort of machine without any real trouble. The answer was yes. The machine itself isn't exactly any good, but the point of the exercise was to find out whether you could or not. There was quite a lot of questions about how to generate the toolpaths in Fusion and even the machine setup in Fusion. So I'll go through that in just a moment. A number of people wanted me to continue developing this, which I would do, but shortly after I made the video on this, I bought this. This is a Sieg SC6, I think, lathe, which has been basically converted to CNC, but it's in bits, and it was cheap on eBay, so I bought this. So this is the next big project. Maybe once this is all working and out of the way, I'll make a little lathe, but this is what I'm going to be spending my time on for probably the next few months. But I would like to ultimately make a little Swiss lathe, because that would be awesome. So before I start, I'm by no means an expert at any of this. I'm just tinkering and learning as I go. So don't take what I say as hard and fast facts. They are just what I understand at the moment. I'm still learning, so it could all be wrong, but I'm hoping that my ramblings will be of some help to somebody. So here we are in Fusion. We've got our very basic part they're going to make. There's a 4mm diameter and a 6mm diameter. So that's it. It's basically two diameters. So we'll do a face, we'll do some turning and a path with three basic operations. So we'll go from design into manufacture. So if we open up the machine library, you can see I've got my GRBL turning lathe, but just for the purposes of this, I will create a new one just to show you how it's done. So on my machines, I'm on local, I'm going to create new lathe. We can call that a GRBL. It's a generic lathe, definitely not a mill turn. It doesn't mill, so we uncheck this symbol here. If I hover over that, you get the tooltip saying supports milling capability. Certainly doesn't, but it does support turning capability. It's not got an automatic tool changer, it's not got tool preload. Some of these finer points like max feed rate and stuff aren't important at the moment. I haven't set them. Kinematics, it being a lathe, has an X and a Z axis, not a Y, so we shall click that and then click the little bin up here to remove it. So we've got an X, a Z and a C, which is the chuck. And I haven't changed anything else in here. There are some advanced settings like the resolution. I mean, potentially we could set that to 0.01, and then it may not ask the lathe to do things that it can't do. Post, this is probably the most important bit. We need to select the correct post processor. This is so that Fusion can create the correct G code for the GRBL board. Let's go to the Fusion360 library and we scroll down to find GRBL. We've got GRBL laser, GRBL turning and GRBL, which is just the straightforward milling, I believe. So we'll select GRBL turning. And it always seems to ask me if I want to copy it locally. It doesn't give me an option to do anything else. So I just copy and it then ends up in this local directory here. Output folders, obviously wherever you want your output files to go. There's no multi-axis stuff, so don't need to worry about that. And I don't think we need to worry about those additional settings. The tool change time I think is probably only for simulation purposes, so it tells you a rough time for a job. So we've got our lathe, close that. So you've got your machine, we want some tools. Tool setup, very similar to milling tools. Lathe tools are very easy to set up. essentially when you create a new tool, you basically tell it what insert you're using, and then put in some parameters to do with the tool itself. Again, some of these things I'm not too sure about, so I've just left them as they are. I think I might have specified this 0.1mm cutting feed rate, and probably this 0.25mm depth of cut, just because I didn't want it to do anything ridiculous. The number in this post processor is the tool number, so that would be, this will be T1, the parting tool will be T2, and that's about, oh, manual tool change is ticked. That's about it for that one. The parting, turning, grooving tool is exactly the same. So there in the library, we now need to create a setup where we can select the machine, which is our GRBL lathe. We are turning or mill turn, primary spindle. The work coordinate system is quite important to get right. If you zoom in a bit, you can see that the chuck is here, and the safe retraction for the tool is over here, which is the wrong way round because we'll be cutting from this direction. So we want to flip Z. So we click flip Z. That puts the chuck back here and the tool safe position here. And you can see that X and Z are in the correct directions. Stock tab. We're going to use some 1/4 inch stock, so 6.35mm. Length 20, that's fine. Model position, offset from front. We're going to offset it 0.5mm. Just so we've got some material to face off. That's okay. Right, so that's our setup done. We'll then do a facing operation. We can select our CCMT tool from the library. I don't think I need to change much on this. Generally what I do is I just say OK and then see what it does. If you get a green tick, it means it's happy. You can then go to simulate. So if we press play, we can see that the tool comes in, does a single pass and comes out again. Let's fix that, because we want to do a, just for the purposes of demonstration, we want to do a rough pass and a finishing pass. So passes, multiple passes, there we go. If we do step over of 0.35mm and a finishing pass 0.15, that'll take our 0.5 millimeter off the end of the stock. Now let's see how that simulates. There we are. It was a bit quick. Comes in, does one pass, does another pass, and we're done. Right, next let's do the profile roughing. Same tool. Maximum depth of cut is 0.25mm, that's fine. We probably want even depths of cut. Stock to leave, we could leave that and do a finishing pass, or we could just say, you know, this is the roughing and finishing pass, so that's fine. That's generated a toolpath. We can see it's got a tick and we can see some lines have appeared. Let's just simulate that just to see what it's done. Comes in and yep, doing a nice few passes there to get to the right size. Lovely. And then finally we will part the thing off. select the tool for the turning and grooving, and I use pecking. Perhaps we'll do that. Pecking depth, I think we'll probably go for 2 millimeters. Means it will hopefully go in and retract 3 times to allow chips to clear. Okay, let's simulate that and see what we get. Tool comes in. Oh, let's watch that again. That didn't seem to come out very much for chip clearance. Let's see what I didn't do. Pecking retract 0.4, that's not really enough, is it? Let's have 5 millimeters retraction, just so it's really obvious what's going on. That's not what I want to do. I want to do simulate. And play. So it comes in, pecks a bit more. That's the part cut off. So essentially that is all I did to create the setup and the toolpaths using my GRBL board. Essentially the GRBL board is just a board that takes G-code and drives stepper motors based on that G-code. There are some special functions in there for turning and for milling and for even for laser, I think, as well. But for the basic functions, it really makes no difference. It's a CNC. You throw G-code at it and it drives stepper motors with the numbers that you throw at it. The next bit is the harder bit, is with your machine is making sure you're happy with where your 0 points are, how to set the tools up. Essentially what I did is I just drove the tool for my demonstration to center, and I eyeballed it basically and set the 0 for the X and the Z, so it knew where the end of the part was, it knew where the center was, and it worked from there. Now normally you wouldn't do that. You would home your machine to 0, which would probably be at the other end of the machine. You may then bring the machine in to work out where the Z0 is. The X0 would ideally be held in tool offsets, so you don't have to set them up per job. If they're still in the machine on the turret or whatever, you would turn a diameter with them, you know, sort of semi-manually, measure that diameter and compare that to what the machine thinks the diameter is, and then add an offset into the controller. I believe that's G41. I have not done that, so I cannot really explain how to do that yet, but I will have to do that when I get my big CNC up and running. So it's definitely something I'm going to have to look into. When I do that, I will probably do another video on how that works. But for the moment, I hope that has answered some questions. One final important thing to remember is if you do want to start playing about with this sort of thing, when you first run it, take the tool out so that you don't crash into anything, because when I did it, it seemed to be doing completely random things until I got my head around what was what, and you get an idea of what the G-code that you're sending it is actually going to do. Right, thanks for watching. See you next time.